Okay, good afternoon, ladies and gentlemen. How are you guys doing? Alright, so let me just check my mic is okay. And alright, today we'll do something really different. In fact, I'm going to reveal one of my secrets. And yeah, if you are a calculus teacher, then you will like this a lot, I assume. And if you are a calculus student, maybe you don't want your teachers to see this, because I will go over how I make my calculus exams harder, right? In fact, nothing too tricky. I'm not going to ask like complicated questions. Instead, all I have to do is the opposite. If you guys look at the title of the handout that I have in the description, I said what? Today, we are not going to be asking for the answers. Instead, we'll be asking for the questions. Yes, we just need to do the opposite. And in fact, that will make the exam so much harder, and you just have to really know the materials in order to be able to answer these kind of questions. And I'm not going to solve any questions today because otherwise they will take too long. I might do another video just to go over everything, especially my thought process and things like that in that video. But today we are going to have some discussions. And in fact, we did this before, but you guys can see that I only did about like maybe 2 or 3 questions in my exams. Not everything are like this on my usual exam, right? So here's the deal. Of course, go ahead and go to the description and download the files and think about this along the way, right? So this time, we need participation. Right? I'm not just going to tell you guys, hey, do this, do that. You guys will also have to think about the examples. Again, we are looking for the questions, not the answers. So without further ado, let's go ahead and do the following. So question number 1, again, we are going to be asking for the examples, the questions. You didn't see that. All right, we're going to see how to give an example of an integral so again, I'm not asking for how to integrate whatever whatsoever, but I want the integral, right, could be done, right, so that it could be done. Perhaps I will just write it the way I wrote it in the handout, so that it can be done with either integration by parts or tricks up. All right, so now I want you guys to think about an integral that can actually be done with either integration by parts or tricks up. And yeah, let's see how it goes. Let's see what you guys have. And then I will try to write down your answers on the board. I also have my answers planned. And in fact, how did I come up with this idea? It's not from myself, it's actually from my students. Because as a teacher, one of the things that happened to me the most is that the students will ask, teacher, can you please give an example of an integral that you can use both integration by parts or tricks up? I've been asked a lot with these kind of questions. Yeah. And later on, we're going to have a lot more fun. You guys will see. So let's see. What do you guys have? What do you guys have? Hello, Adam. How are you? Yay. You're here. You made it. Cool. So we are going for an integral that can be done either integration by parts or tricks up, right? Of course, it has to be doable. So I'm not going to write down the things that's like too outrageous. Let's see. Well, if you do e to the x divided by e to the x plus 1, I don't think you can do it with tricks up. You might be able to, but you know, today we'll just be looking for the integrals, the examples. On the actual test, I will ask the students to actually solve it as well, so I don't think you want to do that. Alright, so I see x times the square root of x squared. Well, x to a third power wouldn't work. I don't think that will be have a nice answer for that. Luca Armstrong, I think I like your answer, so I'll put down this right here. So example by, just say by Luca, right? So the example that he gives us is x times square root of 1 minus x squared. Let's see, can we do integration by parts with this? If you do integration by parts with this, you want to differentiate this, we want to differentiate that. And again, we're just going to talk over it. We're not going to integrate it because otherwise it will take too long. So let's see if we have a... Luca, do you have a idea for this? I know trig sub will work. It's not the easiest method, of course. In fact, U sub works the best for this one, right? And I'm not sure how you will do it with integration by parts in a nice way. Would you just integrate? Of course, do a DI method, of course, right? It's not easy to integrate this though, right? So you might want to integrate this, and then you may want to differentiate that. And is it that going to be easy? I don't know. And again, keep in mind, on the actual test, I will ask the students to actually write down the example and then solve it. But right now, we're not doing the solving part because otherwise it will take too long. So, I don't know. Should we do it the other way? If you do it the other way, if you differentiate x and then integrate square root of 1 minus x squared, that's one, that's easy. But for this, yeah, you will have to use the trig sub or integration by parts. So this is my answer that I actually have, right? My answer. So I'll just put this down right here, my answer. You actually just can look at the integral of 1 minus x squared dx. Yeah, this right here, it's actually doable with integration by parts, where I have a video on that. And of course, the classic way to do it is by trig sub. So that's definitely okay. So yeah, so I would say this one might be too hard. Again, if you put this down on the test, then you have to do this. Yeah, and yeah, let's look at another answer if you guys have any. So let's see. Oh, a lot of you guys are telling me this one as well, huh? So this is like the classic one you can do it with integration by parts and also trig sub, huh? So I think there are more than one people putting down the answer. So yeah, sorry, I cannot write down all the names. Yeah, so if you have this in the chat, that's great. Thank you. And again, I want an integral that can be done with either integration by parts or trig sub. So if you say e to the x, I don't think that would be a good idea. So SMI, yeah, you can also replace this with plus. So yeah, I think if you have the minus version, again, if you think about it, if you're on the test, this is the one that you want to put down because it's okay to demonstrate the integration by parts and it's pretty okay to demonstrate the trig sub. Yeah. So this question actually is like two questions because three questions because the first part is come up with an integral. The second part is, hey, do that integral with just integration by parts. And then the third one is, hey, do that integral with trig sub. Yeah. So you see, if well, if you put something down like this, if you say the integral of, actually let's use blue for this. Yeah? If a student puts down the integral of x times sine x dx, of course this is the classic example of using integration by parts. Sure, but how would you do trig sub on this? I don't think that's good at all, right? So not a good idea. So as you can see, when you are asking for the examples, when you're asking for the questions, it's definitely much harder than just asking how to do the equation. Yeah, so usually I will put like 1 or 2 questions on the test just to, have the students think a little bit harder than usual. Yeah. So today we'll go over three main parts of Cal 2, of course. The first part is, of course, what we're doing, which is integrals, and then we'll be doing limits, and then series. And Alan, and also math nerd, 1729. If you guys are here, stay till the end because the bonus is for you guys. All right, so let's look at the second part. All right, let's look at the second part. Well, this time, you know what? I want an integral that has to be done with both. I'm just going to write down the main part, okay? With both u sub and partial fraction decomposition. Oh, by the way, who just finished the AP Cal B.C test today? If so, just give me a hashtag, finished. Finished. With an ED, yeah. If you just finished the AP Calculus test today, just give me a hashtag finished so I know you finished the AP Cal test. Elliot Chan, okay, cool. And then Gilbert, cool. The frog, okay. Well, Adam, okay. And then almost, why almost? Because, oh, you are taking the AP Cal test in next 3 weeks or so, maybe. Okay, I want an integral. And you must be doing both u sub and partial fractions in the same integral. So how would you do that? All right, so Noah, if you do x divided by x squared minus 1, then u sub will work. You don't necessarily have to perform partial fractions. So you will have to make your integral slightly more complicated. And by the way, I do think about these kind of things a lot when I am making videos because I want to have some creative video ideas for you guys. So usually, yeah, I spend a lot of time thinking about examples as well, not just how to solve the questions. All right, Ethan, let's say what you have. Let's see. Ethan, can you put down your answer again? Because I think I missed that. All right, if you say 1 over x to the third power plus x, I believe partial fraction will work, and you don't necessarily have to perform u sub because you get x times x squared plus 1, right, as a factor. So you don't necessarily have to perform u sub. And in fact, x to the third power plus 1 on the bottom, you can just factor x to the third power. U sub will do the job. You don't even need to do the partial fractions. Okay. You guys are giving me a lot of answers. I'm sorry. If I cannot keep up, I'm very sorry, okay? I didn't expect the comment goes like this fast. All right. Oh, Ethan, I might have missed your message again. I'm very sorry about that because I still cannot see that. But I think I will take Noah's answer because that looks very interesting. All right, so if you finish your AP Calc exam, well, congrats. And I don't know why you are here because you just finished the test. You should go relax. All right, so this is by Noah. So I'm just going to put on your name, yeah? Noah. So your integral is 1 over x times ln x minus 1 and then ln x plus 1 dx. Make this longer and then put a 1 more toward the middle to make it prettier, of course. Yep. So as you can see, first you have to do u sub. Let u equal to ln x, and then of course du is just equal to 1 over x dx. So that x will help this out, right? And you end up with 1 over u minus 1 times u plus 1 in the u world, totally, partial fraction from there. Perfect. Yeah. And this is a great question to put on your test if I ask you this question. Because remember, you still have to do this on the test, right? All right, so somebody said, hold on. All right, so Tony, you said x squared divided by x plus 1 times x plus 2. I believe you can just do long division first and then just partial fraction. You do not need U sub. Yeah, you do not need to use U sub for that. So Nikhil, you said integral of e to the x over e to the 2x. Okay, so I will also put this down because this is a good one. So let me see. Nikhil. And if I have like enough answers from you guys, I'm not going to put down my answer because for this one, it's not so bad. Your answer is integral, and then you have e to the x on the top, and over e to the 2x, and then minus a squared. Perfect. dx. So this is one of the classic one too. That it might look kind of intimidating, but the trick is you do u sub, let u equal to e to the x, and then you see we do have the thing on the top, and then you end up with 1 over u squared minus a squared, and from there you can do partial fractions, even though you can also do tricks up for that, but of course, if the question is asking you to do both u sub and partial fractions in the same question, then you do it like that. So perfect. ln of x squared over sine x. I don't think that works. Yeah, I don't know. skw cosine x over 1 minus sine square x. That works perfectly. And David, square root of tangent x, I think that will be overkill. You don't want to put that down on your own test. Because remember, when you put that down, you have to do it. Alright, Matthew Lee, hello. And then me, I don't think works. ln of x squared over sine x. I don't think that will work out nicely. So, yeah. Alright, so the first two questions are just typical integration techniques, right? So, if you have been doing a lot of integrations, then you should know that. Now, for part C, ready? Remember how to approximate integrals? You have the midpoint rule and also the trapezoidal rule. And usually, you have the midpoint rule and you have the Simpson's rule and you also have the trapezoidal rule, right? Among these three, Simpson's rule is usually the best. All right? But I would like to have an integral so that the midpoint rule, right, Mn is better. Of course, better means gives a better approximation, of course, in terms of the absolute error, okay? So I want the midpoint rule to be better than the Simpson's rule. Simpson's rule. And for this, you also have to indicate some n values for some n value, right? So you have to give an integral, and then you have to say m2 is better than s2. Well, maybe n10 is better than s10. Oops, sorry, I wrote it down wrong. Simpson's rule should be Sn, right? This is the hard one. I actually discovered this by coincidence when I was assigning questions to my students. So I want to see if you guys can do that. So you will have to give a definite integral this time because otherwise you cannot approximate, right? So definite integral, and yeah. All right, so Grubert the frog, if you put down e to the 2x times cosine e to the x, again, you will have to give an integral and then some value a to b and then some function, right? It has to be a definite integral, and then you are going to use the midpoint rule and also the Simpson's rule, right? And in fact, the midpoint rule is better because it gives a smaller absolute error. So this one is not easy. again, as I said, I actually discovered this by coincidence when I was writing down some examples in the class for the students to do, and then I realized, oh my god, how is that possible that the midpoint rule was better than the Simpson's rule? And then of course, there's a reason why, and yeah, usually I will talk about this in class, and for the students who show up to my class and then do the homework or take the notes, they will know this example, and if they see this question on the test, hopefully they remember it so they will get a point, because otherwise it will be really hard for you to come up with this question right on the spot. Yeah. Ruben, e to the x over n, I believe that won't work. Yeah, that won't work. Yeah. And I will give you guys a hint. When you are using the midpoint rule and also the Simpson's rule, remember the error bound formulas. Right? Remember the error bound formula. The error bound. And in the error bound formula, for the midpoint and also for the Simpson's rule, for the midpoint rule, right, you have to look for what? The maximum value of the absolute value of the second derivative on the interval a to b. So you have to pay attention to the second derivative, right, of the function, right? So you have to kind of associate. So I'm going to use, doesn't really, how should I do it? I run out of notation. I think I'm just going to, yeah. In order for you to know this, you better know this, right? And once you have this, this is not regular notation. Midpoint rule. You have to associate that. Let me just use that. You have to associate that with the second derivative of the function, and then in the meantime, the Simpson's rule, you have to associate that with the fourth derivative. Right? I believe the second and also the fourth derivative. So that should give you a hint. And the reason I know e to the x divided by a number won't work, because if you have derivative, then for sure that the Simpson's rule will be better than the midpoint rule, thanks to the error bound formulas. Right? So Albert, you said no. N is not a part of the function. N is the number of rectangles that you want to use for the midpoint rule and also for the Simpson's rule. So you will have to specify, is it M4, M6, S4, S6, and things like that. In your integral, there shouldn't be any N's. Right, let's see if you guys have any. If you have the integral from 0 to 1 x squared, for sure the Simpson's rule will be better. Yeah. In fact, Simpson's rule will give you the exact value if you are just integrating a parabola. E to the 2x won't work. Again, in order for you to have a chance so that the Simpson's rule is better than the midpoint rule, right, you have to think about the derivative of the function. Yeah, again, this is not an easy question. And as I said, I actually discovered this by accident, and I realized, oh, okay, that's why, and it makes sense. So I'll give you guys another 30 seconds or so. If you guys have anything, then I will. Well, if I see any functions that's actually differentiable, then I know they won't work because of the error bound formula. Yeah. All right. So I'm going to erase this so I can have more space to write, and I will tell you guys what the answer that I have, all right? So here is the deal. Keep this in mind, right? The error bound formula. The example that I have is the integral going from 0 to 1, and then I have sine of square root of x dx, right? And for this one, I will have to convince you guys that the midpoint rule is actually better than the Simpson's rule. And before I erase this part, I will just have to tell you, look, for this right here, the integral from 0 to 1 does work. And this is not improper, right? Well, the problem is that if you differentiate this, you have to use the chain rule, and then you have the 2 square root of x on the bottom. Guess what? The first derivative of sine of square root of x doesn't exist, let alone of the other derivatives. So, in fact, if you don't have differentiable function on this interval, right, this might not even apply. So, that's how you can actually have a chance to have the Simpson's rule to be worse than the midpoint rule. So I'll tell you guys the numbers if you do the things. Let's see who is spamming, and I'm just going to yeah, it's kind of outrageous sometimes in the chat that people just get too excited. So I think the person cooled down, and I'm just going to right, anyway. So if you look at this and consider n is equal to 4, right? So I'm just using 4 rectangles. In that case, you will see that M4 is actually approximately 0.60916, and then S4 is approximately 0.59212. All right? And in fact, this integral, if you use a TI or Wolfram alpha, you get approximately 0.60234. Well, have a look. Midpoint rule is 0.609, which is only 0.007-ish away from the value. Meanwhile, this and that is, further away. Yeah, so midpoint rule is better. Okay? And again, if I assign this question on my test, I will actually go over this in class, and then I will assign to make the test fair, just to test the students to see if they actually understand the lecture and show up to the class and things like that. All right. Okay, now let's do an improper integral, part D, and this is the last one for the integral part, right? So we want an improper integral, right? So we want improper. We want an improper integral. Right? And I will tell you, it's both type 1, meaning that you have infinite interval, and type 2, meaning that you have a vertical asymptote somewhere. So this is really improper because it's both type 1 and also type 2 improper integral. But you know what? It still converges. So that's really cool. Sometimes when you have an improper integral, of course, you get infinite area, so that diverges. I want an improper integral that's both with type 1 and type 2 situation, right? But it converges. So the picture is going to look something like this, right? So let's say you put a vertical asymptote S0, and then if you put a vertical asymptote, it doesn't have to be 0 sometimes. By the way, so you have a vertical asymptote, and then you also have a horizontal asymptote. And let's say this right here is some number A, and then that. So you want integral going from A to infinity of some function somewhat like this, because this is the case that you actually end up with both type 1 and type 2 integral, right, improper integral. Because at A, you have a vertical asymptote, and then we go to infinity. So this is what I mean by both type 1 and type 2. All right, so let's see what you have. Well, Alexander, 2 to the negative x, which is exponential, you do not get vertical asymptote. So there's no vertical asymptote, meaning that there's no type 2. So again, this right here means you have a vertical asymptote, just like this picture here. And type 1 means that you have infinite interval. You're integrating like from a number to infinity. Yeah. Is gamma 1/2 both type 1 and type 2? I don't think so. It's t to the 1/2 power. So it's not type 2 because there's no vertical asymptote. It's type 1 because you have infinite interval, right? So that's not correct. Jose, you said e to the negative x times ln x. That's interesting. So let me just put down Jose's answer. And you said e to the negative x times ln x. Now, you have to mention the numbers here though. So where do you want to go? From where to where? From 0 to infinity? Because I assume that if you have 0 here and then you get like ln of 0, right? So I would see, Jose, if you can tell me the limits of integration, then just go ahead and... Yeah, 0 to infinity? Okay. Well, the problem here is that I agree when x goes to infinity, you get horizontal asymptote, right? Because this dominates that. But when x is equal to 0, what's the limit for that? Do we really have a vertical asymptote? Oh yeah, we do. I just noticed that because this is like 1 times negative infinity, so of course we do here. Great, good. But the problem is that, how do we integrate this and then get the value out of it? Because remember, we still have to show that it converges. So, yeah, that might be kind of hard if you want to integrate this and show that it converges. Or maybe you can do some comparison theorem for this. Yeah, because remember, on the exam, not only I'm asking for the integrals, but I will also ask you to solve it. So let's see what you guys have. So Jose, do you have any idea that you want to tell me how we can take up this? Because in fact, I don't know. I don't know how to show this converge in an easy way. And suppose if I am taking the test myself, then this is not the one I would like to put down because I still have to figure out what this is. So I'm not sure though, so that's why I put down a question mark. Gilbert, you said this works. If you can verify the answer on Wolfgang Alpha, you guys, then let me know. But again, the thing is that remember, this is still a test. You still have to do this by hand on the exam. So yeah, I wouldn't put this down so to give myself more trouble, you know. So that's fine. Tangent from 0 to pi over 2, well, that's only vertical asymptote. You do not have the infinite interval. So you are missing the type 1 part. Sin x over x minus 1 from 1 to infinity. That's interesting. So let me see your YOAV. I'm sorry, I'm not sure how to pronounce this And your answer is, though, integral going from 1 to infinity sine x over x minus 1. I can see that there's a vertical asymptote at 1, and I can see that this is type 2. But again, you have to show that this right here actually converges. So it might take me like, I don't know, 2 days to figure this out. I am not. I personally wouldn't put this on my test, like, if I want to answer this question. So if you know how to do this, then again, let me know. Yeah. Because I also want to get to other people's answer. 1 over arctangent. 1 over arctangent from 0. So Leo, right? Let me put on one more. So you said the integral going from, well, you said 1 over arctangent. No, this won't work. This won't work. If you say going from 0 to infinity, right? This won't converge. The reason why is because 1 over inverse tangent. When x goes to infinity, the limit of this guy is 2 over pi. So in fact, the picture will look something like this. Like you have a vertical asymptote at 0, but this number is 2 over pi. Right? And then you will end up with infinite area. Therefore, this right here won't work. Yeah, so I know that this right here won't work for sure. Because one of the criteria is that, of course, if this is like some finite number, then you can see that if this is not equal to 0, then you see that this is 2 over pi, so you have infinite area, so for sure, yeah. I cannot tell you the criteria is this must converge to 0 in order for the integral to converge. That's not true, so that's why I was trying to say it in a careful way. Right? So I'm going to give you guys my answer now, and then we'll move on to limits. So this is my thought process, like how I came up with this, right? I like to differentiate inverse tangent because it has some really nice properties. So if you look at inverse tangent, if you differentiate this, so let me put it down like this. This is how I create integrals. If you look at inverse tangent, you differentiate that, let's say you just have x, yeah? Of course, this is just 1 over 1 plus x squared. 单地哦 not exciting at all, right? You see, this will work if you integrate from 0 to infinity, you get inverse tangent, but this does not have any vertical asymptotes. So I have to create some. Again, let's use the square root things from what we did earlier. So one of the things you can do is you can put a square root. And I kind of want to get rid of this 1. So you see, if I put a square root here, I just have to put a square root here, then this and that will cancel. I want to cancel the 1, so all I have to do is just minus 1 right here. So I just have to minus a 1 right here, right? And that's pretty good. And of course, I still remember the chain rule, don't worry, okay? I'm just telling you guys how this goes. And yeah, so let's say we still want to do the chain rule. So this is 2 square root of x minus 1. Well, this is just going to give us 1 over x, right? And then we have that part. And yeah, you can just pretty much try this from there. Do you guys see it? You see? 1 over 1 minus 1, because this and that cancel, so you just end up with x. And then do the chain rule, then you get this part, right? So in another word, if you integrate this, you end up with that. And when you're working with inverse tangent, you can plug in infinity, inverse tangent of infinity, well, when you take the limit, you get pi over 2, which is finite. Inverse tangent, if you have the input being 0, it's just 0, so that's also good. So you can just play around with this idea. And this is actually one of my favorite questions to ask for my Cal 2 students. So I will put that down for you guys. So this is my answer. I explained the thoughts for you guys already, right? Integral 1 over x in the front, take the square root. In fact, you can have x to whatever power that you want. Let's just put on 3. Earlier I saw that we saw 1 over x times square root of x minus 1. If you integrate that, that will give inverse tangent, right? But in fact, if you have any power here, like 3rd power or 15th power, you can do u sub and things like that. You will end up with inverse tangent as well. But anyway, going from 1 to infinity. Yeah, going from 1 to infinity. Because if you say 0, then that's bad. Because you will have 2 vertical isotopes, right? At 0 and also at 1. So just go from 1 to infinity. Then you can see that this right here is vertical isotope at x equal to 1. And you have infinity. In fact, let me tell you, this right here converges to pi over 3. Yeah, no kidding. And just to remind you guys, the proper way to handle an improper integral when you have an integral that's of both type 1 and type 2 is you split it. The first one, you can do it from 1 to 2 of that. So you just make a cut in between of 1 and infinity, let's say 2 because it's easy. And then you picked up the integral going from 2 to infinity, 1 over x square root of x to the 3rd power minus 1 dx. You actually have to split this into 2 integrals and then do the limits accordingly, and you will see that this is finite and this is also finite, and you combine them, you get pi over 3 for the final answer. This is one of my favorite integrals. Improper wise, not improper integrals. All right, so are you guys having fun so far? Because these are not as easy as the ones that you would do in the regular calculus class, of course. Yeah, coming up with questions is much harder than coming up with the answer. But I do think that these questions are still fair. So this is how I make my calculus test harder than usual. All right, so for number 2, we are talking about limits. And the way that I ask so that it prevents people of doing like some smart stuff is this, right? So I will say, give 2 functions, f and g, right? Give 2 functions at f, so f and g at a. So I will put all this in red because you will have to give the f function and also the g function and also the a value, and a can be infinity, right? A can be infinity if you want it to be. So that, right, so that part A, let's see. Ready? We want the limit of x approaching a of the function is equal to 1, and the limit of x approaching a of the function g is equal to infinity. But actually, I'll put it down right here. Just keep that in mind. Yeah, just keep that in mind. A can be infinity, right? But the limit as x approaching infinity, x approaching a of f of x raised to the g of x function, this right here is equal to 2. In another word, I'm asking for an example of a limit so that it has the indeterminate form 1 to the infinity's power, and this right here approaches 2. You will have to give a function for the base and then a function for the power, and also x approaching to what, right? The a value. And again, a can be infinity. So now, what do you guys think? What do you guys think? Right. We're trying to have an indeterminate form, 1 to the infinity's power, and then we end up with 2 for the limit. So let's see, Monica. X approaching 1. All right, Monica, let me just put that down. And again, you guys can verify all this. I'm not going to do all the computations because otherwise that will take too long. So I'm just going to put the limits together. It saves some more time. Take the limit as x approaching 1 plus. And then the base function that you have is x. Good. And then the power is ln2 over x minus 1. Excellent. This right here will work. This is one of the classic examples, so this right here, for sure it will work. Yeah. And you can verify it. You take x to be, you take f of x to be x. When x is approaching 1, then you get 1. And then g of x to be this. When x is approaching 1 plus, you end up with 0 plus on the bottom. ln2 divided by 0 plus, you get infinity. So this right here also works. And if you do all this, you end up with 2, for sure, guaranteed. So great job for that. And how about if you guys have any other answers? All right. Koryo, your answer and mine are the same. Except for I believe you have to have a plus. Otherwise, you end up with 1/2. So I'm going to fix your answer a little bit, right? So this is by Koryo. And again, I hope to pronounce your name right. If I didn't pronounce your name right, I'm sorry. Your limit is going to be the limit x approaching, well, you have to say approaching what? So I'll wait for you a little bit. But the base is 1. And right here it should be a plus 1 over x. And then the power here is ln2 times x. So I'll write it down ln2 times x. This is great under the condition that x approaching infinity. This is the classic example of having 1 to the infinity's power, right? And it does not approaching 1. In fact, this is what I call the fact, right? You can see that a is equal to 1, and then b is equal to ln2. So this is just e to the ab, which is 1 times ln2, and you get 2. So again, it works. Yeah. Let's see if you guys have any other answers. Okay, Luca, I have not thought about that one, so hold on one sec. And I've been just getting a lot of messages, so it takes me some time to read over it, and yeah. Oh, I know why. Okay. Oh my God, I did not think about that. I will have to change the wording again. Yeah. All right. So, my goodness, Luca. All right. So right here, your your limit is the limit as x approaching 0, right? Approaching 0. Yeah, and then e to the x for the base, and then ln2 over x for the power. Yeah, of course this will work. Man, I have to think about a way to write it so that people don't do this. Because of course you can cancel the x and x, and then arguably it fits the criteria of all that, right? So I will have to think about it. But this is the answer that I will be expecting my students to write, because this is perhaps the most famous example when you have 1 to the infinity's power. So we have 3 examples. You guys can take a look, and great job on this as well, Luca, because based on the things I wrote, and it works perfectly. Oh, maybe because you want this to be positive infinity, so this right here you will have to say 0 plus. Yeah, just a little touch for that. Yeah. All right, so calculate. Yeah, it's the same thing, and I run out of space, so I'm going to move on to the next one. And okay. All right. For the next one, I'm just going to change what? Let's see. Okay, I'm going to just change these numbers so that I don't have to write everything again. You know, for the next one, I actually thought about how to prevent people from doing the obvious. I will talk about that. And yeah. So for part B here, right? I want this right here goes to infinity, and then this right here goes to infinity, and let's see. I'll just write this right here. The limit as x approaching a, f of x minus g of x. I want this to be 2. Yeah, it's all about 2. So infinity minus infinity approaches 2, right, in that form. And again, to prevent people from doing the obvious, I actually wrote it down on the paper already. Right? So this one, I actually thought about it. I don't want you guys to say, hey, do x plus 2 and then do x. I don't want you guys to do that. So another condition that I have is that I actually put it down all the way in the front. I want f of x minus g of x not to be 2 for any x. Right? I wrote it down. Right? I wrote it down on the paper. Okay? So, all right. I want to see what you guys have. Oh my God, Noah, you serious? Let's see. Man, how can I phrase it so that I can actually get this to be hard? Like for limits, I feel it's really hard for me to phrase it in a way that people. I want to prevent smart answers, you know. I don't know, but like. Okay, Noah, yes, I will take your answer. If you put this down on my exam, I will give you full credit for this. So Noah's answer, I'm going to just put it in the limit format. Noah's answer is the limit as x approaching infinity. Ready? X plus 2. And then he said minus x. And that's exactly what I don't want you guys to do earlier, right? Now this is exactly what I don't want you guys to do earlier, right? Because I have that. But he has this. So is this legit? Yes, this right here, it will be legit. Man, I really want to think about like a way to phrase it so that people cannot give me smart answers for this. Yeah, because of course you can always simplify inside and then, yeah, I don't know. I want to have an example of infinity minus infinity approaches 2. So, okay. Well, x plus 3 minus x plus 1, that will violate this. Yeah, so that won't work. So Astro, like, your answer won't work because I have this condition. Alright, Milan, this is the answer that I have as well. This is the answer that I have as well. You can see I put it down right here in blue. Yeah, so you read my mind. That's one of the classic example. So I'll put that down. And let's use x because we're talking about functions. So this is the limit as x approaching infinity. This is the kind of things that I will be happier to see, you know. X squared plus 4x and then minus x. This right here does give you 2. Right? And for this, you can do the conjugate and then take the limit after that. So, not so bad. Jorge, let's see. Wow. Wait. Am I reading the same? Let me see. All right, so let's look at Tafish music. You answer. Huh. So X is, get rid of X. Yeah, it works. I really don't want you guys to do the subtraction first and then simplify the function tremendously and then just get a 2 though. So I don't know. I think I'm just going to move on to the next one because I think I just cannot prevent you guys giving smart answers for that. Let's see. Jose, let's look at your answer. Oh, that's a fun one. So we'll do that. This is also another one that I had in mind as well. So Jose, this is the answer that you will have. The limit as x approaching infinity, ln of e to the second power x. And then you want to do square plus 1, okay? And then minus ln of x squared plus 1. Cool. And then, of course, the big parentheses right here. Sorry, run out of space. Of course, you combine the natural logs, and if you take the limit, you get ln of e to the second power, right? And then you have just equal to 2. So this right here equals to 2. So yeah, this one. Pretty good. At least we cannot do any simplification inside. So maybe I'll just have to say somewhat like f of x minus g of x cannot be simplified. Yeah. Cannot have any subtractions for things like that. I don't know. But anyway though, that's part B. And let's also do another one. Oh, I shouldn't erase the limit because it's the same thing over again. You guys ready for the next one? C, right? So we want the limit as x approaching a of the function f to be 0, and then the limit as x approaching a of g of x also equal to 0, but the limit as x approaching a of f of x to the g of x power is equal to 2. Yes, it's 2. So for this question, of course, we're looking at 0 to the 0th power is approaching 2. Right? So try to give some more of the more fun answers. Alright, let's see. I'm not going to write down anything that you can simplify right away. Because, okay, one of the things that it's not I want to do this to you guys, it's like the students do this to me as well. Because when I'm teaching limits, when I show them 0 to 0, sometimes you approach 1, sometimes you approach 2, right? And my students will ask, hey, can you please show us the limit 0 to the 0th power, and you end up with 2. And I don't think my students will like it if I simplify the answer. If I just say things like, if I can simplify anything, that's the how can I do this one if you can reduce? I don't know. Yeah, I don't know how to do this one with I cannot come with like let me just use your examples. Let's see. The negative x. All right. Charez, your answer is e to the negative x, and then ln 2 over negative x. X going to infinity, I believe. Yeah. But again, let me just use this. Let me just tell you guys like this, okay? If you ask an instructor to demonstrate 0 to 0 is approaching 2 in class, and the instructor puts this down and say, check this out. This does go to 0, and this right here does go to 0 as well, and then see this and that can cancel, and in the end you just get 2. It's like, wow. Yeah, so I will try to not put down any answers that can simplify right away, all right? Because my students will get mad at me in class too. So yeah, I will not put down any answers that you guys can simplify right away. Yeah, so with that being said, Milan, yeah, I'm not going to, let me see, multiply by x. Yeah, I'm not going to write down any answers that you guys can simplify right away. All right? I just have to think about a way to phrase it so that you guys cannot do that. I don't know how to phrase it. It's more like the thing that I explained it earlier. If my students ask me that, if I show them a limit that you can simplify right away and just get the answer like the obvious way, then they wouldn't like it. Yeah, I've been a teacher. I have done that before, so that's why. Anybody? We want a limit, 0 to the 0 is approaching 2, right? And do not simplify this part. We cannot simplify this right away, right? Look at ln x to the 1 over x. What's the a value? Oh, sorry, you say that's the f of x. But yeah, give me the complete answer, because I... All right, this x approach, so Kai, your answer is x approaching 2, 2 over square root of x raised to the square root of x power. Do you mean this? So this is from Kai. So the limit as x approaching 0. Wait, if you say 2 over square root of x, then you don't get 0 for the base though. So this won't work unless I'm reading your message wrong. So if you write it in another way so I can see better. So terminology, how does 0 to the 0 approaching 2? That's exactly what I'll show you, right? So that's why this question is much harder than the usual limit question. Oh, I see. Okay. You know, the reason I put this down is to prevent people doing the obvious as well. So Kai, your answer is 2 square root of x raised to the square root of x power, right? I agree that this right here will give you 2. Why is this 2? Because this right here is the same as 2 times the limit as x approaching 0, square root of x to the square root of x power, and this part is just equal to 1. And this is like the classic 0 to the 0 situation, right? And I put this down so that, you see, you cannot identify f of x being square root of x with the 2. Yeah, if I put this down, you will have to say f of x is equal to 2 square root of x. Hold on. Yeah, so because the way I write it, like this, and then assuming that you cannot simplify f to the g right away, you actually have to do this. Yeah, because I don't want you guys to write a limit and then just have any constant multiple. So that's why I put this down like that. And yeah, I really just have to think about a way to say that you guys cannot simplify f to the g power right away. So this right here, it's not going to work. And again, I'm speaking up for myself. I'm not just like, being demanding to you guys. It's like the students will demand this kind of things from me during class. So I have to think about this right on the spot too. All right. Mr. HK1636, what do you mean it does work? And then Kai, if you can think about a way, yeah, feel free to let me know. But just because I said it like this, you cannot have the 2 square root of x to the square root of x power. Yeah, because you are saying f of x is 2 times square root of x. Yeah, that's what I showed you earlier. Yeah, square root of x to the square root of x power when x is approaching 0, 0 plus technically, I believe it does approach 1. You can try it on Wolfgang alpha real quick. Again, I'm not doing all the math, so. Man, there are a lot of people just spamming the chat, so I'm really sorry. I really have no idea. I don't know how to control this. And then people just get crazy with that, asking me math questions, even though we're talking about this, they still want to ask that random questions. Yeah. So if I cannot get to your message because I'm like trying to approve or disapprove messages, then I'm sorry. And then if I see somebody that's spamming the chat, then I will have to put the person in timeout. So, yeah. If the person wants to get mad at me, then I don't care, because, yeah. Okay, so Mr. HK1636, you said, that's like the one I have, yes. So I'm going to put on your answer and I'm going to put on mine, right? I'm going to put on your answer, I'm going to put on mine. So this is from Mr. HK1636. So check this out. Here we have the limit as x approaching. Approaching what? I assume it's 0. Technically, it should be 0 plus then, because you are using the natural log. So x raised to the ln2 over ln x power. This right here is good because you cannot cross things out right away, like the things I told you guys earlier, right? But the truth is, you can still kind of cross things out because x is the same as the x is the same as e to the ln x power and then raised to the ln2 over ln x power. So you can technically still cross things out. This does give you 2 though, right? This does give you 2, don't get me wrong. Don't worry though, here's my answer. This is how I fix it. So you actually get a function because in fact, this right here is actually just a constant. When you have x to the ln2 over ln x power, this is actually just a constant. One little touch, you can just put a 1 plus right here and then you will fix everything. My answer is the limit as x approaching 0 plus x raised to the ln2 power over 1 plus ln x. This right here is a function, you'll see the change, and it will be approaching 2. Yeah. So this is the one I have in mind. Yeah, this is the one I have. And this right here, they are not easy for me to come up with, and then a lot of this are actually from experience. And I will demonstrate this in class, and I'll tell my students, hey, check this out. 0 to the 0 does approach 2. And yeah, do you guys have any other thoughts? Then let me know real quick. All right, Milan, you said, wow. Oh my God, which one is that? Wow. Have you checked it? Does that really give you 2? Let me see. So Mina, I'm going to put down your answer and then you can tell me. Yeah, so I'm going to write this down right here real quick. So this is by Milan's answer. The limit, x has to be approaching 0, otherwise it doesn't fit the criteria. And oh, you have the 6 on the outside though, because if you have 6, remember you have to put f of x and then raise to g of x, and the g of x you have is x to a third power. So if you put this and then the other thing is x cosine x Well, how did you come with this? That's like, wow. And then minus sin x. Yeah, I have no idea. I have never seen this limit before, so you will have to let me know. Yeah, so I'm not sure. I'm not sure about this. But again, in fact, I have this idea before, right? Because e to the ln x to that, it's always 2. But if you want to make it slightly more interesting, just put a 1 plus and it will still work. Yeah, it will still work. All right, part D. Part D, I'm sorry. Part D, the only thing that will change is f of x is going to be going to infinity and then 0, and then still the same thing. But here, it becomes infinity to the 0th power approaching 2. This is also an indeterminate form, right? So I'm going to, I have to drink some water, I'm sorry. And then, yeah, so think about it and then I'll be back in like a minute or so. No, not even a minute, like 10 seconds or so. Well, Raphael, if you say g of x is equal to sin x, then that does not work. Oh wait, you said the limit, you said the a value is equal to 0, right? Okay, I actually don't know about that. Again, for that, I will have to check. So, this right here is by Raphael. Okay, you say g of x is sin x and f of x is 2 over x. So, altogether, you are saying the limit as x approaching, it has to be 0 then. So you are talking about 2 over x raised to the sine x power. Like this? Can you guys verify if this is indeed equal to 2? Because I do not know about this. I do not know about this. It does satisfy the conditions that we have, but I do not know if it works or not. So I'm sorry about it. All right, so Kai, what does this give you? You say it's 1? Oh, so this right here is only 1. Yeah, is that what you guys are telling me? So if it's 1, then it does not work because we're looking for 0 to 0 is approaching 2. Yeah. Okay, so unfortunately, this right here is actually 1. So this right here does not work, right? So I'm going to erase this, and then I'm also going to erase this. Give you guys another 20 seconds or so. And then in fact, I think I'm going to leave number 3 to you guys because as I told you, usually have every Tuesday I have a class at 3:30. So I want to have enough time to rest a little bit, and then I still have to do the shout out. So I want to do the bonus after this question, right? So I'll skip number 3 for today. All right, Army Forever. I see your answer. Let me put that down because this one I think, again, this one I don't know. So I'm going to put on Army Forever. This is on me forever, forever. And again, if I didn't put down your answer, I'm sorry. And then I'm looking for the answers that I have not seen before. And let's see, you're saying the limit as x approaching what though? Infinity, okay. And then f of x is e to the x. Okay, that satisfies this, that's good. And then raised to the ln2 over x. Huh, hey, that's well, come on. Simplify the x again? No, let's not do that, right? Let's not do that. I didn't see that. Maybe you can try this. Maybe, okay? I won't be too mad. Try this. 1 plus x. So that you cannot simplify the x right away. Yeah? And let me know if this is still 2 or not. So go ahead, please. Let me know if this is still 2 or not. Hey, the evil mathematician. Good to see you. But I think let's just talk about this. If we put down 1 plus x right here, does this still give you 2? So let's take a look on that. Does it? Hey, David, how are you? And then I'm really sorry. Yeah. Frankie, Luca, perfect. So if you want to have some harder question for students to do, or maybe some functions so you don't cancel things out right away, just add a little 1 to it. This is nicely equal to 2. So like from you guys, it checks. Perfect. You know what my answer is? It's still this. I have not yet erased this out. You know why? The only thing I have to change is infinity. The limit as x approaching infinity, x to this power, it will still give you 2, which is really cool. And just to show you guys the graph for this real quick, right? If I remember the graph correctly, it should be like when x is... How can I make this equal to 0? Let's see. Wait, there's infinity. When x is e to the negative 1, the bottom is 0, so you actually get like this, and then like this. Somewhat like that. And this right here is actually 2, and you cannot get to 2. Can you have x equal to 0? You cannot have x equal to 0, so it's open circle. And this is 2. Yeah. So that's actually the graph for it. Pretty cool. And how can we get 0 here when x is 0? No. I don't know. I forgot the graph about this, but like, so yeah, it's pretty much when it's approaching 2, when it's approaching 0, you get 2, and when it's approaching infinity, you also get 2. So I kind of forgot about this part. I should have drawn it on my paper, but I forgot. Anyway though, I'm going to let you guys have fun with question number 3 because we spent a lot of time already for question 1 and 2. So hopefully you guys all enjoyed it so far for integrations and limits. And for third part, it's about series. I would like to do today's special question, right? So again, try question 3 on your own, and maybe I'll make that into a video just for question number 3. All right, so here's the deal. I don't know if Math Nerds 1729 is here. I'm not sure, Alan, if you're here or not, but they were here last week, and I was going over one of my previous Cal 2 exam about sequence and series. And this is the question that I have. Again, asking for an example. So let me write this down right here for you guys first. First, I want to shout out to Alan and Alan, I think that's how you spelled it, or maybe I'm very sorry, I kind of forgot, or maybe I forgot, Alan, how you spell your name for that. I might be just erasing the right answer, but Alan, okay, Alan and Math Nerd. 1729. And of course, you guys should know the number of 1729, right? So I just want to talk about this question. Again, here we are talking about give an example. So give a sequence AN so that this time, I'm going to break it down 3 parts. So we'll have fun 3 times. Part A, all I want is the series as the series of AN. The infinite series of AN goes to 0. So perhaps you can give me the bound right there. Doesn't really matter. Oh, sorry. This is how I write it. Give a series. This is how I put it down the handout. Give a series. Give an infinite series, but you can have any starting value right here that you want, okay? Infinite series AN, so that, right, part A, all I want is the series is equal to 0. So this is level 1. I should actually say this is level 1. Yeah, I think I will say that this is level 1 of the question. Level 1. And again, this is the bonus part for today. Level 1, I want a series. I want a series to be equal to 0. Right? So give me a formula that will give you 0. That's it. That's it. Yeah, oh my god, I have to always look up the chart. Yeah. All right, so I got rid of that person and oh yeah. Okay, so here's a story, and this is the Alan and math nerd question. Level 1, I just want a series to add up to be 0. So you can do however you want. You can do however you want, right? This not I don't have too much restriction on this. So tell me the answer that you want. All right. Ismail, you said 0 times x to the n. That's a little bit, you can simplify that a little bit, because this is the only condition I have. And David, you said, that's a little bit too complicated as well. I'm not sure if that will work. All right, on me forever. Yes. If I've only put this down, all you have to do is the series of 0. And again, you're going to just tell me some n values and also infinity. So this right here will do the work. Level 1. Level 1, right? Level 1. All right, level 2. Level 2. Here's the condition. I want AN not to be equal to 0, and pay attention to the wording. I said for all n, and then the series, again, you can give me any starting and also the infinity, right? So up to you. But the series, the infinite series of AN, does equal to 0. So this is level 2. And this is where Alan and Math Nerd jump in. This is the question I did last time. And again, it's kind of like a bad wording question, but it turned out to be really fun. So I want to share this with you guys. All right, Raj, you're right. You can do. Then this is exactly what Alan did to me last time. So for this, you can just do 1 and then -1 and then 0, 0, 0 and so on, right? This is totally okay. Earlier, because I didn't have any restriction, this right here is just saying 0 plus 0 plus 0 and so on, so on, so on. Of course, that's equal to 0. But when you put this down, if you add them up, of course, this right here will be 0. However, how would you come up with a formula for this? How would you come up with a formula for this? So now the question is, You can do 1, -1, 0, 0, 0, right? Let's just talk about the sequence right here. I know you can use a I know you can use a piecewise definition. You can just say A1 is equal to 1 and A2 is equal to -1 and A3 and above is just equal to 0. That's fine. But the challenge that I gave out last week is, can you give me just one single formula? One single formula for this right here. One single formula. No piecewise. Right? No piecewise. That's the formula. That's the challenge that I gave out last time. Again, for this right here, in fact, Alan did this to me last week as well, because based on the wording, you see an is not equal to 0 for on. This is legit, because the first two terms, they are not equal to 0. So I got kind of upset, mad, or like, I don't know. And then I gave the challenges that give a formula. Do not use piecewise definition for this sequence. So I'll wait for you guys a little bit and I'll tell you guys the story for that. Man, there are a lot of people spamming in the chat. That's just annoying. So hold on one sec. Let me just clear this a little bit. All right, so just answer the question right now, okay? Otherwise, I'll have to. All right, calculator anomalous. Well, this is what I wrote down last time. an not equal to 0 for on, and this is equal to 0. And Alan's answer was this. This is legit, because an is not equal to 0 for on, because the first two terms, they are not equal to 0. So this right here satisfies this condition. Yeah, I will give you guys level 3. Level 3 is the one that I realized I should have put down last time. So this is level 3. But I want to talk about level 2 with you guys. Level 3, I will have to say an not equal to 0 for any n. And there's a difference between for all versus for any when you say it. Level 3, for any n, but the series of an does equal to 0. If I say an is not equal to 0 for any n, then in that case, this right here won't work, because you see the 0 right here. You don't want any an to be 0. But again, if you say an is not equal to 0 for on, this is okay. Yeah. And I'm sorry for the people who enter the expressions in the chat. I think just because we use so many math notations, so the YouTube chat will think that's a spam and then just blocked it. But if I see you're answering the question, I will try to show the comments. Yeah, so I have to monitor this myself, and that's a lot of work for me to do. So yeah, so just be patient a little bit. I will have to go through the comments myself and all that, so yeah. All right, anybody has the answer for this? I just want a single formula for 1, -1, 0, 0, 0 forever. -1 to the n is not going to work, unfortunately. Joel, your answer, I don't think it will work, because I don't think it will produce a 0 at the end though. You want to have infinitely many zeros after that. So, Alright, I give you guys 10 more seconds. If you have the answer, then just leave it in the chat. Alright, SMI, let's see. I'll give you guys a hint. Use sine or cosine, right? Sine or cosine. No, I'm talking about level 2. Level 2, yeah. Again, the question right now is, we want a sequence, right? So that you get 1, negative 1, 0, 0, 0. You cannot have n to the infinity's power. Infinity is not a number, so you cannot do that. Right. For the people who really want to think about formula for 1, negative 1, 0, 0, 0 without using any piecewise definition, then maybe you want to turn this off because I'm about to tell the answer, right? So if you want to think about this on your own, just kind of leave for like 2 minutes. Well, actually, I will put down the answer on the board. So, yeah, just depends. If you don't want to be spoiled, then maybe you want to turn this off and then think about it and then come back to the video and then look at it, yeah? But anyway, I thought this was really hard. So I gave a challenge last week, especially to Alan because he gave me this sequence, right? But after like 2-3 hours after the live stream, my viewer, math nerd, 1729, he sent me a message on Twitter with a formula for this. And I would like to share the formula with you guys, which is genius. Have a look. AN is equal to, again, the hint is use sine, all right? Yeah? Okay. 2 over square root of 3. And assuming n start with 1, right? N start with 1, n start with 2, and n start with 3, and n start with 1, and then 2, 3, and so on. Here inside, ready? 3 pi over 2. Check this out. When n is 1, sine of 3 pi over 2 is square root of 3 over 2, which cancel out and you get 1. When n is 2, then you will actually have sine of Wait, I am going to check the answer real quick. That's maybe I put down a wrong answer rule. Hold on, let me see the message. I wrote it down wrong. I'm sorry. It's not 3 pi over 2. Yeah, that was my bad. 2 pi over 3. Yeah, 2 pi over 3. Wrote it down wrong. 2 over square root of 3 sine of 2 pi over 3. All right, let's do this again. Check this out. When n is 1, sine of 2 pi over 3 is square root of 3 over 2. Multiply with that, you get 1. When n is 2, you put it here, 4 pi over 3 times sine. It's going to be negative square root of 3 over 2. Cancel that out and you get negative 1. Good. But we also want to we also want to get the zeros though. You know what he did? Ready? Right here, it's not just n, but rather you have n factorial. And when we are talking about sequence, this is totally okay. And check this out. When n is equal to 3, you put it here, 3 factorial, 4 factorials, and later. This right here is going to be a multiple of 3 when n is bigger than or equal to 3. So you see, the n factorial will cancel out with the 3 because this is always going to be a multiple of 3 when n is bigger than 3. In another word, here you're always going to get sine of 2 pi or pi. I don't know how many pi, but sine of whatever pi, right? It's just an integer multiple pi, you get zeros. This works perfectly. Yeah. So this is great. This is so wonderful. I wouldn't come up with this myself. You know his name, no lies. Yeah. Don't you think this is mind-blowing? I'm sorry, I wrote it down wrong earlier though. I thought it was 3 pi over 2 pi, it's 2 pi over 3. So this is totally legit. n factorial instead of the sign. Amazing. Yeah, so this is the one I really want to talk about today, right? This is the a special question. And again, just based on the wording, based on this wording, this is okay. So if you want to use this, it's perfect. Level 3, right? I will have to say an is not equal to 0 for any n. And I went over this last time already, so I'll just put down the answer for you guys. The one I use is sine x power series, which is the series as n goes from 0 to infinity, and then we have negative 1 to the n over 2n plus 1, factorial that, and then x to the 2n plus 1. And we know sum of pi is equal to 0, right? Oh, by the way, there's no way to get an odd multiple of pi earlier because you have the 2, so it's always even multiple. Yeah, but doesn't really matter. You always get 0. But anyway, just that x equal to pi, put it here, then you get the series as n goes from 0 to infinity, and you get negative 1 to the n over 2n plus 1 factorial, and then pi raised to the 2n plus 1. And for this guys, none of them is 0. So it satisfies this condition, an is not equal to 0 for any n. But if you add them up, you know this is going to be sine of pi, which is nicely equal to 0. Just like that. Deserve a very happy face. Just like that. Alright, so that's all I have for you guys today. And again, you guys can try question number 3. Today was a long live stream. Hopefully you guys all have fun. And try number 3 on your own. To summarize all this is how I make my exam harder, by simply asking the students to give examples. Again, I'm not asking for the answers, I'm asking for the questions. But you still have to solve your own questions. Anyway, that's it for today. I'll come up with ideas for next week. See you, bye.